We've only got 5 days until we have to physically start moving the locomotive. We've got 5 days to go through and clean all the roller bearings and do a whole series of work underneath the locomotive that we could not do while the locomotive was sitting out in the museum. The asphalt paving was all the way to the top of the display track, so there was no way for even a skinny guy like myself to get underneath and perform the inspections and dismantle all the components that we have to inspect and reestablish all the lubrication that needs to be attended to and just do everything that we have to do to move the locomotive. So we had to physically get it out to where we could start working on it first. And there it is. And I'm quite proud of the guys. Look at that panel track. It's probably hard to see, but there's a lot of plywood in there, but look at how straight that is. That's pretty good. These guys are good and very determined. Another thing that I was worried about, I kind of stay up late sometimes going through all these scenarios, is California has a lot of earthquakes. And I thought, my goodness, we get this locomotive out on some ground, and even after we've done all the utility assessments and everything, we could encounter some things that are unknown to us. And all of a sudden, we've got the locomotive stayed somewhere, and we come up with an earthquake, and next thing you know, we come out and the locomotive's kind of leaning a little bit. So we were very, very careful. Every time we left the locomotive, we secured it with multiple chains, but we made sure the track was very, very stable and absolutely level. And luckily, we didn't encounter any earthquakes. There were several while we were there, but we never felt any out at the actual display. They seem to occur at night. And I don't know if anyone's been through an earthquake, but the first earthquake that I experienced, it was something else. I felt like a semi-truck ran into the hotel we were staying at. And I realized, I had goosebumps just explaining it to you. It was quite something, you know, to experience Mother Nature. So that was something in the back of our minds. And here's another view of that track. We've got all types of different plywood and 2x6s, and we've got that track shimmed up. And it's amazing how much plywood can bear. And that was the strategy too, is that we did not want to damage any underground utilities, damage the parking lot in any way. So we were very careful in distributing that weight over a very large surface area. That's a really interesting shot. Once we got on the other side of the parking lot, we had to turn the locomotive. In order to do that, we had to swing the track out in one direction, move the locomotive on that, and then take the track that we were just on and swing it in the opposite direction. And so we were coming up with a process of turning it in a very little tight space over there. The other challenge that we faced is a locomotive. It sat for so many years. The centering device spring, all of those parts of the locomotive that need to flex, that need to articulate, hadn't really moved in a very long time. And when the locomotive was in service, the locomotive, as it operates, it oils itself through a system of what we call force feed lubrication. So there's various lubrication points all over the locomotive that are just flooding with locomotive oil. Well, as that locomotive sat stationary for decades, that oil slowly began to coagulate and eventually turn into a very solid mass of an oily mud. And some of it was quite hard. Well, now the challenge is you've got all this very hard stuff that at one time was lubricant, and it's in an area where other parts need to move against each other, roll against each other. So we had to physically get in there and try to free that stuff up, and there's areas that we could not access. So that was the challenge. So it was one thing to start turning the locomotive, and when we first began to turn it, we all marveled, because, you know, an articulated locomotive is a fascinating piece of machinery to see move. We finally got it out there, and you could see those components that had broken free. And we cleaned up everything on either side of that, and now there's an area that is a little bit dirty. So we had planned to stop everything and then clean that area up, service those parts that we can now get to, and then begin to move on. The other challenge is the panel track that we used was second hand. A big articulated locomotive, any piece of rail equipment wants to go on straight track. It likes that. When you put it into a curve, you're putting lateral forces on the rail. So we had to be very careful and diligent and guard against rolling that rail over. Had that happened, that would have been very, very problematic. It wouldn't have been the end of the world, but we would have had to get additional equipment out there, and we probably would have damaged things. We would have been careful not to damage the locomotive, but the heavy equipment necessary to physically pick the locomotive back up while you straighten the rail out under the locomotive was something we were not going to do. And that's why it took us as many days as it did, because we were so careful. We could not afford having that locomotive into a curve and then 2 or 3 rail roll right over. And then we'd have an earthquake. That's part of the locomotive side rod hardware. We serviced all that prior to even moving the locomotive at all. We had a plan to strategically go through and remove pieces here and there. Parts of the locomotive, they have to be positioned just so in order to remove the wrist pin, for example, or to be able to access certain parts of the running gear.
Kelly and Hook. Kelly and Hook, please come to the front information booth.
So while we would work on one part, we'd access and disassemble everything we could, and then we'd move it again, and then we'd access and disassemble the next part, and then at that time, reassemble the other part. And so it was really choreographed to try to get everything done. And we had work gangs working on components that were removed, and we'd stage that material, go through, clean everything, set it aside, get it ready for the reassembly, because time was of the essence. We were in the process of negotiating these timelines, and the timelines seemed to narrow the closer we got. So there was a lot of pressure to get the equipment, everything serviced and ready to go. One of the final moves is we swing around to get it ready. And now we had the great cutover. That was quite an experience for us. We had tremendous cooperation and a lot of coordination with Metrolink and their maintenance away contractor. Outstanding work. Again, lots of planning, lots of coordination. The plan was just to cut the track over. And when you first propose an idea to a commuter rail authority like that, you can imagine the raised eyebrow reaction you're going to get from the engineering people. So we just continued to work through all those processes and assure them that the process would work, and we won't tie up your railroad all night. But there was a little bit of stress and anxiety on the part of many. Now we're coming back, and we're just about halfway to Pomona. Coming in the West Colton Yard. The first few switches we went through, facing point switches, we all began to get a certain comfort level with the locomotive. There were things that we really couldn't identify until we started moving it. And there's always a lot of risk associated with moving any piece of equipment that is stationary for a long time. And that's why we were so careful and so thorough in taking the time in California. So we did not have a big situation on the main line where we had anything at all. As we began to move the locomotive, it was something. We hadn't moved it that fast going across the parking lot, maybe 2 or 3 miles an hour max. There was a plan early on. We wanted to build a little piece of test track. And we were not able to do that because of the NHRA commitments and the other physical limitations we had. So we didn't have any test track out there. So it was, I really think this is going to work. But with our decision makers, we talked about all these details well before we even officially approached the organization to give the locomotive. So there were no unknowns. The plan was known to all the decision makers, and they made the decision to move ahead with the project. Now it's our job to execute that plan. There's a lot of pressure, you can imagine, when you have an executive vice president who's in charge of the entire operation of the railroad make a comment to you. You're not bringing that home on the rails, are you? And to which my reply very respectfully, sir, if we can't get it home, it's not worth restoring. Enough said, be safe. So we were very careful and very, very blessed that the Alco Jabelman Union Pacific design is so rugged, durable, and such a well-designed machine. And we continued to experience that all the way home. The first few miles we were very slow. I had planned to not go over 10 miles an hour, and we developed a schedule to reflect that. We began going, there was no issues at all. I called the engineer running the engine on the other set. I said, take it up to 18. And we went ahead and off we went. And then you began to hear small little surface imperfections in the tires where they had sat in the same location for years. And that type of wheel defect, we evaluated that very, one of our initial things when we moved the locomotive to confirm that it was not a federal defect that would render some compliance problems for us. They were small little rust particles and the locomotive, think about a steam locomotive tire remaining in the same place for decades. You know, is it safe to move? Is the tire condemned? Will the tire break? I mean, there's a lot of things to explore and a lot of analysis that you have to really get into the engineering side of it and confirm that you've got good equipment. And we did all that. Well, now we're going to move it, and you can hear the thing. And that was the cadence all the way home. And the two engines would get in sync with each other, and it would kind of lope a little bit, and they would get out of sync because the diameters are different. And all the way home, we experienced that. Kind of lull you into this state as we were going along. But it's a bit unnerving because steam locomotives, they're supposed to be smooth. And even though you've got all those dynamic imbalances, we had the pistons removed, we cooked the main rods on, so we did have some good balancing there, but the locomotive does have a special sound, a special feel to it. Now, we've done more work in California, and now we're going to bring the hospital train down from Cheyenne, Wyoming. And that is our support equipment and two very special locomotives that for years were just two locomotives on the roster. We selected months in advance. Again, it's part of a railroad organization that loves its heritage and supports the heritage program. I've got some very good contacts we do in the locomotive planning, in the Harriman Locomotive Planning Group. And they were very eager to set aside the UP 4014 ST70M and the UP 4884. And they ran those through the shops, made sure all the inspections were current, and they forwarded them to Cheyenne, Wyoming, where we assembled into our hospital train, and off we went. And most of us rode the train out there. So that was fun for us. It was fun for me because I didn't run it. Sit back and ride and have a good time. We're out in California. Everybody wants to ride the train. Who wants to drive the truck? Rather than spoil somebody's day and say, hey, you got to drive the truck today, we've got all these beautiful flat cars which serve several purposes. One of which is provide additional braking, and the other is to be in compliance with the one-time move authority that was granted by the Washington office of the Federal Railroad Administration. Because the locomotive brakes on the steam locomotives would not be working, it's a requirement that we maintain at all times at least 85 or higher % in our operative braking. It's a railroad rule. Well, to make sure that we had that, and it's hard to find cars that don't have graffiti on them, and I don't know about you, but I'm kind of bothered by the graffiti on the railroad cars. So I figure the flat cars are going to serve a couple purposes. They're lower profile, they're less likely to see graffiti. They also have good handbrakes. So every night when we tie up, we can secure the train safely, and we can also put our material on. Thank you. Thank you. So there's the truck. And this is a special shot for me. This is the 4014 diesel on the right, and the big boy 4014 on the left.